Okay, here's an example where we have a linear function, negative x minus 1, whose domain is x is less than negative 4. So I've highlighted that piece and I've highlighted that domain of negative 4, and everything less than that would go to the left. Then we've got the square root function where x is greater than or equal to negative 4, and I've highlighted to the right on the x-axis. The only thing that's missing here is we need to highlight the domains in these tables. Now I made the tables just slightly different than I have in the past, just looking to give you different types of tools that you can use, and then use the one that's most comfortable for you. They all work. I've got a table that's for the linear function, negative x minus 1, and I've got a table for the square root function. Now the only values that I can put into the linear function are when x is negative 4, actually x is less than negative 4, not including negative 4. So I'm going to start with, negative 4 right here. When I put a negative 4 in, I'm going to get an open circle. When we put a negative 4 in, the opposite of negative 4 is 4. 4 minus 1 is 3. So negative 4, positive 3. And that is an open circle. Now I need to go to the left where these orange values are. So that would be negative 5. So when I put a negative 5 in, the opposite of negative 5 is 5. 5 minus 1 is 4. So negative 5, 4. Then I'll put a negative 6 in. The opposite of negative 6 is 6. 6 minus 1 is 5. Then we'll put a negative 7 in. The opposite of negative 7 is 7. 7 minus 1 is 6. We'll put a negative 8 in, and that's all I'm going to be able to fit on this table. The opposite of negative 8 is 8. 8 minus 1 is 7. And you can see the pattern. It's going to go off the grid just like that. And there is one piece of our piecewise function. Now we've got the closed circle that we have to worry about. So I'm going to come over here and I'm going to put a negative 4 in. This time this result is going to be a closed circle. When I put a negative 4 in, we get negative 4 plus 4 is 0, and the square root of 0 is 0. So negative 4, 0 is an open circle. Then I'm going to go to the right, so we'll put a negative 3 in. Negative 3 plus 4 is 1. The square root of 1 is 1. So negative 3, 1. And I can use the little 1, 3, 5 rule here. Or I can still put values in. If I put values in, negative 2 plus 4 would be 2, and the square root of 2, I would need a calculator. So we'll go to another value. If I put negative 1 in, so we're working our way this way, negative 1 plus 4 is 3, and the square root of 3 requires a calculator. We'll put a 0 in. 0 plus 4 is 4, and the square root of 4 is perfect. So we'll put a 0 in, and we get the square root of 4, which is 2. So 0, 2. And the next value that we can put in would be a 5. When we put a 5 in, the square root of 5 plus 4 is 9, which is 3. So we put a 5 in, and we get a 3 out. And we know that this is going to continue to the right forever, just like that. If we try to see if it passes the vertical line test, we'll find that it does. And that is our graph. So what I'd like you to do is maybe think about trying to graph this one. Yes, it's a different function. This is a horizontal line, and this is a parabola. So you're going to have a piece of a horizontal line, and you're going to have a piece of a parabola. Give it a try. However, if you're not quite sure about that horizontal line, you can always try example number 5 when we get there. So I'm going to continue and finish in this video this problem here. When x is less than or equal to negative 1, those will be my inputs. And when x is greater than -1, we'll highlight that part of the x-axis. When x is less than or equal to -1, we'll have a closed circle. And when x is greater than 1, we will have an open circle. So this first piece does not have an x. So this is the same thing as saying f of x equals 3, which is the same thing as y equals 3, which is a horizontal line. So no matter what my inputs are, my outputs are going to be 3. So I can start down here at -1, and knowing that when I put a -1 in, I'm going to get a closed circle out. When I put a -1 in, I get a 3 out. So -1, 3, closed circle. When I put a -2 in, I will still get a 3 out. When I put a -3 in, I get a 3 out. When I put a -4 in, I get a 3 out. In fact, no matter what we put in, we are going to get a 3 out for that piece. Now, these are all closed circles. The only potential open circle you're going to have is at this value right here, so at this input. But for this piece of the function, x is less than or equal to -1, this equal to means that you're not going to have any open circles. You will have closed circles here. The second piece, you will have an open circle. And the second piece is going to be a quadratic, and -1 is what we will put in to that quadratic to get our open circle. And when we put that -1 in, -1 times itself is +1. So we put a -1 in, we get a +1 out, and that is an open circle. Now moving to the right, I would put a 0 in. And when we put a 0 in, 0 squared is 0. When we put a 1 in, we would get a 1 out. So I'm just continuing to move to the right of the domain because that's where we have our orange inputs. When I put a 2 in, I get a 4 out. And when I put a 3 in, I'm going to get a 9 out. So this quadratic is only part of the curve, and it is that part right there. Okay, what I encourage you to do right here is to try this one on your own, see if you've got it, and then come on back and check your answers. Okay, you've noticed probably that I am starting to work the problem out, knowing that you have either already paused it or that you're not going to be pausing it and you're going to be watching. But if you're watching, then that's fantastic. I'm glad that you're at least watching. So thank you. Okay, so we've got these yellow inputs. If I put a -10 in, -10 squared plus 1, you might be used to highlighting all of it. And that's okay, you can highlight all of it. I'll go back and highlight all of it. When you put a -10 in, because -10 is part of this yellow input, -10 squared is 100, 100 plus 1 is way off the grid. So I'm going to come in and maybe do a -5 squared. When I put -5 in, -5 times itself is 25, plus 1 still off the grid. So we'll try -3. -3 times itself is 9, 9 plus 1 is 10. So when we put -3 in, we're going to get a +10 out. Yikes! Right there, +10 out. When we put a -2 in, -2 squared is 4, 4 plus 1 is 5. When we put a -1 in, -1 squared is 1, 1 plus 1 is 2. So when we put a -1 in, we get a 2 out. When we put a 0 in, we get a 1 out. When we put a 1 in, it is going to be an open circle, and 1 plus 1 is 2. So we've got a partial parabola. And now the other piece, we're going to put a 1 in because that's where the two highlighted colors meet. This time when we put the 1 in to the purple piece, it will be a closed circle. So our output will be a closed circle. That's the only potential place where you're going to have an open circle, is at that point where what I like to call is a boundary point. So at this boundary point, every other point is going to be a closed circle. All of those will always be closed. So when we put a 1 in, the square root of 1 minus 1 is the square root of 0, and the square root of 0 is 0. So we put a 1 in and we get a 0 out. If we put a 2 in, we're going to get a 1 out. If we put a 5 in, we get a 2 out. And if we put a 10 in, we're going to get a 3 out. And that is our video. And that concludes our lesson on piecewise functions.